Welcome to an introductory video examining a few commonly used geospatial processes in ERDAS Imagine. We'll be using the spatial modeler, and this includes manipulating file names, layer stacking, unsupervised classifications, logical operators, sieves, clumps, indices, masks, and then some manipulating of attribute tables as well. So hopefully these things are all very useful. I will say there's ways to make this model much more aesthetically pleasing, and you can make it more organized, or you could break it down into submodels or use some iterators in there if you need, or the multi-file name input should you need to go that route. But for example's sake, I'll just leave it like this. And I'd also like to say that I did not create the main core of this model that separates out snow, water, clouds, and shadows. You can find that on ERDAS's website. That was created by another geospatial scientist, but I did amend it and tweak it a good amount, as well as add to it. So basically what we have here is one Landsat scene, and it's got clouds in it, and it has some cloud shadows, some different densities of clouds. It's got snow. It has north-south running mountains that also create shadows, different densities of vegetation, also some urban areas and dry areas, as well as deeper reservoir water, and then shallower lake water. So quite a bit of diversity in terms of the spectral responses that we're going to get. But we'll jump right into the model here, and what we're looking at is starts with band 10 input. So this is a port input, and you can configure it so that it brings in data, files, rasters, and if you haven't used these before, they are highly useful, so I recommend it. And you can put the notes in here of what it'll bring in, and this will pop up in the user interface when you go to run the model. I'll just do that right now. Band 10 input, and you locate where the file is via that, and it's got different options there. So what this does here is it turns it into a string. So it turns it into text, and you can manipulate that text. So it takes that file name and then turns it into a string, subtracts some characters from it, and then adds onto the end or concatenates other bands. So now we have band 1, and we run this into the model. We could do it with band 9 up there. It's done with band 6, 5, 4, and all the way down. And importantly is when we turn the file name into characters or into text or string, we need to return it back to a file. And so you can go in here and change to whatever you need to change back to before sending it into the processing operators. So what does this do? Well, this brings in all these different bands with the click of 1. And we have a layer stack here, so we get a multispectral image of it. It's a 7-band stack. That's what the indices I'll be using require. This also uses bands 3, 4, and 5 to separate snow and ice and water. So it goes through and does that based on spectral response. And then it uses the snow and ice and compares that to thin clouds and thick clouds, which is calculated by unsupervised classifications up here, including band 10. Right, which gets at temperature. So it's one of the nice things about the Landsat-8 suite. This is another port input. So if we were to, let's click on that, see what it says. So it says, well, basically it just says, do you want to dilate clouds or not? And that means that we'd search around the clouds. We'd increase the cloud just to be conservative about the pixel alteration that we're receiving on the fringe of clouds that the model might not identify as clouds. And when we click this run, it brings us up in the interface. Do you want to do that or not? So then the model keeps going, goes down here, some more logical operators, greater than, less than, or equal to, either ors, another unsupervised. Then we get at shadows, and this is to say how far around cloud pixels should we search for shadows, because we want to find shadows that are related to the clouds also, not just that we might have missed otherwise. So it goes through, does that, and then you can set to how much you want to dilate around the cloud. So this is the actual mask, right? This is when it brings in the clouds and the shadows here, and we want to add attributes to that. So we put this custom input table, and what you'll see over here with the mask itself is, these are areas that are cloudy. These are the orange areas are shadows. So when we go to set that, we want to say if 1, set it to red, if 2, set it to orange, and so forth. So that's the 1 there, the 2 there in that conditional statement. Then we create that as its own column, and then we use the attach attributes operator and then plug it right into this raster output. And so this is that mask, right? So you can see that again. Pretty good, not bad. You really need to zoom in, and we need to do, of course, quite a bit of accuracy testing on this to be sure, but the more we zoom in, the better we can get an idea of how that works. So that's that. So moving along, set this criteria as we go into mask out the clouds. We want to go in and be able to, let's zoom in a little bit. We want to ensure that only certain pixels are kept. So in this conditional statement, we say, all right, of all the reds, if it's greater than 0, then keep it, or then mark it as something you want to mask out. And I have that here set to true, so it does that. And what we'll see, we have the mask, right? And then we bring in the masked image, and it's the same original multispectral image, but without those pixels. You can invert that and keep only what's under the mask if you click false right there. So it just depends on how you want it set up. And then towards the end, I just ran a few indices that are commonly used in my field, whether they be different vegetation indices. We've got soil adjusted vegetation index, green, normalized difference vegetation index, and then regular NDVI, and the normalized difference built up index here. And each of those outputs its own raster. So, and what do those look like? They look a little like this. So it just depends on which one you're using, and they are a little different depending on which vegetation index you use. So anyways, hope that's helpful for you. Let me know if you have any questions. I'm happy to try to help where I can. Take care.